Okay, in the last couple of videos, we've been trying to emphasize that the matrix representation of a linear transformation or a linear operator depends on the basis. And so that brings up kind of a natural question. What if you want to change your mind about which basis you're using? So suppose that you know a matrix relative to one basis, and you want to find the matrix relative to a different basis. So the idea being that you know the matrix A is how you would turn V relative to first basis into T of V, but how would you turn V relative to a different basis into T of V relative to that different basis? So I'm using B prime instead of B1 and B2. This is not a derivative, it's just a different B, different basis. Okay, so it turns out that's not super complicated to think about. We just have to kind of stare at and try and investigate the relationship between these four vectors, all of them being column vectors because they're all coordinate matrices. Okay, so what we know is that A is how you would turn this guy into this guy. And we're trying to find out what is the guy that does the same thing down here. How do we turn V relative to V prime into T of V relative to B prime? And something we have going for us is that these two on the left actually represent the same vector, just relative to two different bases. So we actually talked about a change of basis matrix before that would turn you from B to B prime. And so we're going to do the same thing over here. We're going to use a change of basis matrix to go from here to here. And then we just have to figure out which change of basis matrices is it going to be. And so the idea is if I want to figure out this bottom line, if I want to get from VB prime to TVB prime, I just take a little detour. Instead of going straight there, since I don't know that matrix, I do know all the matrices along the way, and I just go up and over and down. So I'll take kind of a detour to get from this vector to this vector to this vector to this vector. Okay, so let's see if we can write that down and figure that all out. So our final answer is going to be this, T of V relative to B prime. We're going to start with this vector, V relative to B prime. And the first thing we're going to have to do to V, the thing that's going to hit it first, is going to be a transition matrix. And the transition matrix should change it into basis B. So starting in basis B prime, ending in basis B. Again, it really helps to write your P's as PB, B prime. And so if I just stare at these two together, this should spit out V relative to the B basis. So I guess that's my inside operation. Once I know V relative to the B basis, I'm going to apply the matrix A, or multiply it by the matrix A. And so that answer, first doing this change of basis, then multiplying by A, should give us this vector, which is T of V relative to the B basis. That's not what we want, though. We want T of V relative to the B prime basis, so we're going to need one more change of basis. So going from basis B to basis B prime means we need the B on the right and the B prime on the left. Remember, it's just like dimensions of matrices. The ones on the inside cancel out, and you have whatever's left over. So the B primes cancel out, we have B left over. Now we have B's canceling out and B prime left over. And so I think that should be it. And so our change of basis matrix, getting from VB prime to TVB prime, is going to be this product of three matrices. Each of these should be a matrix. And if we're talking about a linear operator, meaning our domain and codomain are the same vector space, everything is going to be a square matrix. So everything is nice and simple in that sense. They're all going to be n by n matrices. One other thing that I'm going to emphasize, if one of these matrices is P, then the other matrix is the inverse of that P. It's doing the opposite. One goes from B prime to B, the other one goes from B to B prime. And so the matrix for the linear transformation relative to B prime is going to be related to the original by multiplying by P and P inverse on both sides. Let's just call it this. Okay, so A prime is going to be P from B to B prime times A times P from B to B prime, which we could also write if we wanted to, sliding up a little bit, we could also write this as A prime is equal to P inverse AP, which should look really, really, really familiar because we've seen this exact operation before, having a matrix on one side and its inverse on the other side. That's how we defined diagonalizable or similar matrices. So I'll come back and visit that in more depth in the next video. I think this is where I'm going to stop for now, but my point is that the two ideas are connected. Changing a matrix from one basis to another is somehow related to similar matrices, and in particular A and A prime are similar.